You're on camera.
Alright, so we made a dog camel. I'm Marcus, and this is Tucker. And the main point of our 401, yeah.
401, yeah.
And the main point of our project was to try to get a robot to walk on 4 legs and then recognize a wall and try to turn away from the wall when it sees a wall and then continue walking. The biggest problem really was trying to get first to balance on 4 legs so it wouldn't just topple over right when it started its movement. And then after that, the biggest problem was trying to get the legs to work in unison so that it wouldn't just get stuck and shuffle in one spot.
Which it still might do.
So let's give it a run here and see what it does. You got it.
There you go. Yeah. See, when it comes to a wall, it shuts off the left side and tries to turn to the right.
Which is getting a little stuck right now.
And then
Moonwalking, that was actually the second point of the project, to get him to moonwalk.
there.
I love the tail. The tail's great.
Go backwards.
So is the right side still shut off right now?
So the right side has been turning on and off of it, but right now it's off.
I think the light is messing with it.
That's weird.
Hit the big flip switch, the
There you
paddle.
go.
Yeah, there we go.
The other one.
Now it's broken up.
Right to the left of us. There you go.
Oh, yeah.
The video still looks good, so we can.
Oh,
So you made about 2 feet. I think that's one of the best runs so far. Oh wait.
So while he's doing there, what's the mode of getting legged motion of everything?
Getting the legs in the right motion. So we tried to make him kind of gallop so that he takes one step and then the second step. Because when he steps at the exact same time, he gets stuck, as you can see.
So yeah, we're trying to get like the back leg come forward as like the front leg come back as the back leg's coming forward, so that it kind of steps with the toe as the back leg's coming forward, and that helps with these longer back legs too, to try to get it on course. And it works the best when these 2 front legs are in unison.
Whoa!
Oh, there goes the leg.
Alright, so that's our robot.
Hold on, guys. Hold on.
Yeah, so just a
Stay up there, please.
couple of questions. So what was the hardest part?
Well, most of the robot was actually doing the mechanical functionality of it, getting it to actually walk, so that was probably the hardest part. We did have a lot of trouble getting the IR sensor to completely work the whole time, just because it was messing with the push button that we had implemented. So like the while loop would go into the push button, and then it wouldn't go through to check the IR sensor every time. We had a little bit of trouble with that, but the main problem was
To get the legs to work in unison.
So-
the biggest
so it was mostly mechanical.
Getting
And I
it-
think-
hardware.
And I think if we had some more time to work on it, putting some encoders in to keep the legs in motion so that there could be like an error function to make sure that the legs are actually staying in the right motion, that would probably be the biggest thing that we would have been able to do, but we just didn't have time to also include the encoders. Spent most of our time trying to get them to balance.
And what would you say the most important thing you learned?
That easy projects aren't as easy as they sound.
And also backing up, like the motor drive was also a big deal too, because what happened there was that this got pulled out because of the drive here was not long enough, so it got pulled out.
So we had to put like a tensioner in here to hold that pulley in place.
Yeah.
So I'm
Hold it
glad.
from both sides so that it'll hold itself up as the wheel is spinning on the inside.
I'm glad you brought up the drive. That was going to be one of my questions in terms of the mechanical design. Thinking back to Lab 1, what was the requirement for any shaft coming out directly from the motor?
to have another piece that it connects to so it doesn't get pulled down,
Right.
Yeah.
So
The backup,
right.
yeah.
I don't.
which is kind of what this pulley is doing.
The
Yeah, we
pulley's doing
definitely-
it.
We definitely
That
have
that
the-
pulley here is with the rubber band is holding this up.
Oh, I see. So you do have some support on the other side
Yeah,
of the
without
beam.
that, maybe he'd walk for like a couple seconds and then that piece would get pulled out of the motor.
Gotcha. Okay. So I did not notice the pulley. So I'm glad you guys at least addressed that in that fashion.
So
Yeah,
it's a flexible bearing.
exactly,
Yeah,
yes it is, because it's got the rubber bands, so it's just holding it up into it.
Any other questions? And you call this
Dog camel?
dog kennel, all right.